Hello everyone, this is the video of limit continuity. In this video, we'll be learning what is limit, how it is represented symbolically. We'll do some problem related to limit. We'll see the interval in which a function is continuous, and also we'll see where the function is discontinuous. Or we take point discontinuity. Next, we will also see the nature of function by knowing the limit of the function. So, getting to the first topic, what is limit? So, limit of a function is the value that function approaches to or gets close to when the input to that function gets close to certain number, which is represented by limit x tends to a at x. If this is equal to b, we say b is limit of function f x when x tends to a. What does it mean graphically? So how will we find the limit of function graphically? We'll see this in this slide. So graphically, this red curve graph for certain function f(x), and we'll see what is this f(x) equals to when the input, that is x, this is the horizontal line, this is x, when x tends to, let's say x tends to 1. When we say x tends to 1, x is not exactly 1, but it's close to 1. So you see, when x is close to 1, that is this point and this point, both are close to 1. And we'll see what this function get close to. So when x is close to 1, we see the function value is either this or this. If you see these two values, they are very close to what? Close to 1. So we can say when x tends to 1, limit x tends to 1 at x is equal to a 1. Let's see another case also, or another example again in this same figure. Let's see what would this function approach to when input to this function, that is x equals to minus 3. This is minus 3. So a number that is really close to minus 3, let's see, this is close to minus 3, and these are close to minus 3 from both sides, you will see. And if we see the functional value, again this functional value, so here you see again this point, this and this. If you see these 2 points or these 2 functional values, we see that functional value is getting close to 5 when input to this function, that is x, is close to minus 3. This is the way we will find limit of function graphically. We'll see what that function is getting close to when input is getting close to certain value. We have a term called left hand limit and right hand limit. In left hand limit, we will see, for example, we will see limit something like this: x is to a minus f x, limit x tends to a plus f x. This is a way of representing limit, left hand limit and right hand limit. But what does it mean is, previously we say in limit the value or the input should approach a certain number. But when we are approaching to certain number, or when we are getting close to certain number, either we are a little less than that number or we are a little more than that number. So if we are getting a little more than the number that input approach to, that is a minus means a little less than a. We need to find limit x tends to a, and we find f a minus is a little less than a, that is the input getting close to a, and we can also find f a plus, that is a little more than a, then that is also input getting close to a, or that is also a input is close to a. Then we say limit x tends to a minus fx, which later limit, which is we are putting the value of a little less than a. For example, it could be little a minus, and when the input is taken a little more than the a, then we say that is right hand limit. Let's suppose this is a plus, then we say it is a right hand limit. In graph, we see previously left hand limit and right hand limit both are getting close to 5. That is left hand limit and right hand limit are equal in this case, but every time it may not be same. For example, in this blue graph, if we need to find limit at x tends to 2, let's see what will be the left hand limit and right hand limit in this case. If we say left hand limit, we need to put the input a little less, that is a little less than 2, that is less than 2 is, let's suppose it is 1.9. F 1.9 in this function, if this is 2, f 1.9 would be the function less than 2, will be taking this function. F 1.9 is nearly this value. Similarly, if we put a little more than 2, that is f 2.1. 2.1 is a little more than 2. So we need to use the function x square plus 4. In that case, when x is 2.1, fx will be equal to this value. So you see, there are two different values when x is less than 2 and x is greater than 2. In this case, we say left hand limit and right hand limit are not equal. If these 2 points were same, we will say left hand limit and right hand limit are equal, or it do not need to be same, but it should be really close to each other. Then we will say left hand limit and right hand limit are equal. When left hand limit and right hand limit are equal, we should say limit exists. Again, let's see how we find the limit of a function from the table. We should see again what the function fx approaches to when input approaches to certain number. In this example, we are taking the function fx equal to x plus 3, and let's see what is the limit of this function when x tends to 0. So when x tends to 0, we should see what is this function approaching to when x is approaching to 0. So x is approaching to 0 means from minus 2 is getting to minus 1, minus 0.5, minus 0.25, that is getting close to 0. When it's getting close to 0, what is this function getting close to? Let's see, from 1 it gets to 2, 2.5, 2.75, getting close to 3, right? It's getting close to 3. So we say limit x tends to 0 and x equals to 3. Next way also we can do, here you see I am increasing the value of x and getting close to 0. I can also decrease the value of x and get close to 0, right? So from 1 I get to 0.5, from 0.5 I get to 0.25, that is close to, that is getting close to 0. And we see what is this function getting close to. From 4 it is getting close to 3.5, it's getting 3.25, so it's decreasing and getting close to 3. So I can increase the input and get close to the value that I should, that the input should get close to, or the input value, or I could also increase the input or decrease the input and get close to the certain value and see what is that function getting close to. Here you see when x is increasing and getting close to 0, function is getting close to 3. Similarly, when x is decreasing and getting close to 0, again the function is getting close to 3. If we forget this part, and only see this part and say limit x tends to 0. We cannot say 0, but we should say 0 minus, because we are not getting more than 0. We are only saying less than 0 and seeing what this function equals to. X equals to 3. Again, if we need to see the right part, that is also called as right hand limit. Limit x tends to 3. Oh, sorry, x tends to 0. X tends to 0. But we are not taking more than 0. We are not taking less than 0. We are not taking more than 0. So we should write 0 plus x equals to 3. So this is left hand limit, this is right hand limit. You see left hand limit is 3, right hand limit also 3. When left hand limit equals to right hand limit, we say limit x is. In this case, we can write limit x is now 0, not minus, not plus. Limit x is to 0, fx equals to 3. So your limit x is x is to 0, and it is 3. You see, in previous graph, from this table also, we see limit of function if x tends to 0, it's same as the functional value f3. So if limit of function is equal to functional value, why are we finding limit of a function? We could simply find the function value, simply putting the value of x as 3 and getting, x is 0 and getting the function 3. Why don't we do this only? Why we need to find limit? You see in previous slide, sometimes limit may not exist. Sometimes it could also be possible that there is hole in the function that will read in other slides. So there are also some indeterminate form. If you see, this green graph is the graph of the function fx, which is defined by 5x divided by 2x squared plus 4x. And you see what is this? What is the value of this function when we put x equals to 0? Okay, when we put the value of x as 0, let's find f0 is equal to 5 into 0 is 0 divided by 2 into 0 square, that is 0, 4 into 0 is 0, so 0 plus 0 will get 0, that is 0 divided by 0. So is the function equal to 0 divided by 0 when x equals to 0? No, the function has certain value. And next, what does this 0 divided by 0 mean? It's an indeterminate form. Usually we take 0 divided by 0, infinite divided by infinite. These are indeterminate forms. And in this case also, we'll try to find what is the value of function by using limit. We'll see what does that function approach to. We don't need the function to be exactly given point. For example, in previous, we do not see what is the function exactly 0. We only see what is the value of function when it is the input to that function is nearly close to 0. Like you put minus 0.25, like you put 0.25. You can even get more close to, like you can put 0.1 and minus 0.1 and 0.1 and see what that function is getting close to. Similarly here also, we do not see what is the value of this function exactly 0, x equals to 0, but we will see nearly close to 0. And when we get indeterminate form, we have some technique. We will do some algebra to this function and try to remove 0 divided by 0 form and get the value of function or limit. Previously I discussed about hole. In hole means the function is continuous up to here. There is no value, or value of this function is not here, but somewhere. For example, we are coming from here, up here, we know the function is continuous, but here it is discontinuous, and the function value x equals to 0 is minus 2. Again, when x increases, again the function starts from here and gets this way. Here, where the function is discontinuous, or we also call it as point discontinuity. In this case also it's useful to find limit of the function. If you see why the function value at x equals to 0, it's minus 2. But is the limit of this function if x tends to minus 2 equals to minus 2? No. If you see, let's see, let's limit and write a limit. If you see, when x is approaching to 0, that's coming from this side, the functional value is getting close to this 1. Similarly, if you come from right hand side, when we are decreasing the value of x to get close to 0, we see the function is again approaching to 1. So here you see the limit of this function is 1, but the function value is not 1. So here we see limit and function value are different. Now we see indeterminate form, and how we will be solving the indeterminate form and finding the limit. Let's see an example. Here x square minus 3x plus 2 divided by x square plus x minus 6. We need to do some algebra. First of all, let's see what will be this when x equals to 2. When we put the value of x as 2, we see 2 to the power 2 minus 3 into 2 plus 2 divided by 2 to the power 2 plus 2 minus 6 is equal to 2 to the power 2 is 4 minus 3 into 2 is 6 plus 2 divided by 4 plus 2 plus minus 6 is equal to 4 minus 6 plus 2 is 0. 4 plus 2 minus 6 is again 0. So this is the indeterminate form. So we'll do some algebra and try to remove this 0 form. In this case, we can do factorization. In this case, we could do factorization. So we will see this function limit x tends to 2. This will be equal to limit x tends to 2. X square minus 3x plus 2. In place of this, we can write x square minus minus 2x minus x plus 2 divided by x square plus 3x minus 2x minus minus 6 minus 6. This would be equal to limit x tends to 2. Let's take x common from this two terms. X minus 2. From these two terms, we can take minus 1 is common, we have minus 2 divided by, again take common x from these two terms, x plus 3 minus 2 x plus 3. This will be equal to limit x tends to 2. If x tends to 2, so you see x minus 1 bracket x minus 2 divided by x minus 2 x plus 3. So if you know algebra, we can call x minus 2 and x minus 2, and then this would be equal to limit x tends to 2 The remaining is x minus 1 divided by x plus 3. So now, if we put the value of x as 2, let's see, it would be equal to 2 minus 1 divided by 2 plus 3, which will be equal to 2 minus 1 is 1, 1 divided by 2 plus 3 is 5. So the limit of this function when x tends to 2 is not 0 divided by 0, but it is 1 divided by 5. Another way of finding limit when there is indeterminate form, for example, here if we see when we put the value of x as 4 in this function, we will get 3 minus 2 under 5 plus 4, that is 9 divided by, when x minus 4, x minus 4, we need to write 4 in place of x, we will have 4 minus 4. This is equal to 3 minus root under 9 is 3. 3 minus 3 divided by 4 minus 4, which is equal to 0 divided by 0. So this is an indeterminate form. So how to remove this indeterminate form and find the limit? We again need to do some algebra. In this problem, we need to do rationalization. So what